Hello friends, I am Dr. Padma Taneja and welcome back to my channel Maths Expert Tutorial. Today we will discuss the concept of differentiability of differential calculus. Let y be a function of x, then the rate of change of y with respect to x is known as derivative of y with respect to x. With respect to x. And in case of differentiability, we have to find the right hand derivative and left hand derivative of a function x at x is equals to 0. We can find right hand derivative and left hand derivative as rf dash 0 is equals to limit h tends to 0 f of x plus h minus f of x upon h. It is known as right hand derivative, and left hand derivative is f of limit h tends to 0 f x minus h minus f x upon minus h. If this both derivative exist and are equal, then we can say that the function fx is differentiable. Let's take one example. We have to check the differentiability of fx is equals to mod x at x is equals to 0. First of all, we will take its value as x when x is greater than 0, minus x when x is less than 0 and 0 when x is equals to 0. Now we will find its right hand derivative. Rf dash 0 is equals to limit h tends to 0 f 0 plus h minus f 0 upon h. That is mod 0 plus h means when x is greater than 0. So it will become equal to 0 plus h minus 0 upon h, that is equal to h upon h, that will be equal to 1. And now we will find left hand derivative, that is L f dash 0 is equals to limit h tends to 0 f 0 minus h minus f 0 upon minus h, that is minus of h minus of 0 minus h minus 0 upon minus h. It will become plus h upon minus h, which will become equal to minus 1. So here we see that right hand derivative is 1 and left hand derivative is minus 1. Both exist but are unequal. So we can say that the fx is equals to mod x is not differentiable. Now take another example. Fx is equals to x sine 1 upon x. When x is not equal to 0 and 0 when x is equals to 0. So its right hand derivative is equals to limit h tends to 0 f x plus h minus f 0 x, or we have to check at 0. So we will write f 0 plus h minus f 0 upon h, that will be equal to h sine 1 upon h minus 0 upon h. Cancelling this h, we will get limit h tends to 0 sine 1 upon h. And we know that the value of sine 1 upon h is finite and oscillating between minus 1 and 1. So its value is not unique. Similarly, we will find left hand derivative, that is L f dash 0 is equals to f 0 minus h minus f 0 upon minus h. So it will become equal to minus h sine 1 upon minus h minus 0. So cancelling this minus h, we will get sine of minus 1 upon h that is equals to minus of sine 1 upon h. Similarly, its value is also finite but oscillating between minus 1 and 1. So, we do not get a unique value of right hand derivative and left hand derivative. So, we can say that the function f(x) is equals to x sine 1 upon x is not differentiable. Now, take another example, which is f(x) is equals to x square sine 1 upon x when x is not equal to 0 and 0 when x is equals to 0. So, we will find its right hand derivative and left hand derivative. Its right hand derivative will be limit h tends to 0 f 0 plus h minus f 0 upon h, that will be becomes equal to h square sine 1 upon h minus 0 upon h. Cancelling this h, we will get limit h tends to 0 h sine 1 upon h. As we see in the last example that the value of sine 1 upon h is not finite, but when we multiply it by 0, it becomes 0. Similarly, left hand derivative Lf dash 0 is equals to 0 minus h minus f0 upon minus h. It will also becomes equal to h square sine 1 upon h upon minus h. Now, cancelling this, we get minus h sine 1 upon h. But when we multiply sine 1 upon h with 0, we will also get 0. So, here we see that both right hand derivative and left hand derivative exist and are equal. So, we can say that the function x square sine 1 upon x is differentiable function. So, to check differentiability of a function, we will find right hand derivative and left hand derivative. If they both exist and are equal, then we can say that the function is differentiable. Thank you.